He has a host of publications, 100 or more. He has all kinds of awards, the highest civilian award for Navy service. So he comes with tremendous credentials. He also happens to be a very good speaker. So I'm happy to turn it over to Mike Clancy.
Thank you, Jim, for that wonderful introduction. And I also want to thank George Riley, Robert Evans, and of course, Howard Fossler for setting this up for me. Second time I've spoken to this group. I'm a big fan of the League of Women Voters. I'm really super happy to be back here again today. Now I'm going to share my screen here. And pretty quickly, I'm going to be going on to my slides. And I would invite everyone to adjust their view. I think you can make it such that you can see both me and the slides at the same time. It's most important that you see my slides. So if there's anything obscuring the slides, you want to try to minimize that. Here's a quick outline of what we're going to be going over today. Start with introduction and context, talk a little bit about the science there, just kind of set the background, then we'll jump right into climate change denial, end up talking about what needs to be done, some closing comments. During the question and answer period, I'll be happy to address any and all climate change denial arguments you may have heard. And that's one of my favorite things to do, is to debunk climate change denier myths here. So jumping right in, what we're looking at here is a plot of global mean surface temperature of the Earth by year from 1850 to 2017. Now, global mean implies averaged over the entire face of the Earth from pole to pole all the way around. Surface temperature over the ocean is the sea surface temperature over the land and over the ice-covered areas. It's the temperature a couple of meters above the surface. And it's a plot here of that global mean surface temperature of the Earth from 5 different independent sources using 5 independent data sets. And the point is, they all paint the same picture. The picture is as follows. Not much change from 1850 to 1880, slight decline from 1880 to 1910, pretty strong upward movement from 1910 to 1945, from 45 to 75, a slight decline, and then beginning in the mid 70s and continuing to the present time, strong upward trend in temperature such that the Earth is now running about 1.2 degrees centigrade above the pre-industrial level. A couple things to note here. Note the very close agreement between these 5 different sources. That indicates the fact that the climate system is very well observed and we have a very good handle on it. Also note that the temperature doesn't go up in a straight line. It's kind of like the stock market. You know, there's volatility in the stock market, there's volatility in the temperature record. These zigs and zags here, what I'm referring to as volatility, in fact, it represents climate variability distinct from climate change. Climate variability occurs on timescales of months to decades, about the scale of the Pacific Ocean. It involves things like El Nino, La Nina, the Atlantic multi-decadal oscillation, lots of these kinds of variabilities that occur regionally around the world, distinct from climate change. Climate change occurs on timescales of 30 years or longer. If you're looking at something, a temperature record someone shows you that's 20 years or shorter, you're not looking at climate change, you're looking at climate variability. 20 to 30 years, that's kind of gray area. You really want to be looking at trends that are 30 years or longer. 50 years or longer would be even better. Now I'm going to show an animation of the NASA product. And what we're going to be looking at here is temperature anomaly from 1880 to 2018. Now, temperature anomaly is just a fancy way of saying temperature difference from a reference field. And in this case, the reference field is the 30-year average from 1951 to 1980. Here's the temperature scale over here, where you see white depicted on the chart. It means that the temperature, in fact, is the same as that reference field, that 30-year average, 51 to 1980. Where it's yellow to orange, it's warmer, and the dark oranges are 2 degrees centigrade warmer. The dark blues are 2 degrees centigrade cooler. Pay particular attention to what happens in the mid 70s. I'm going to call out the years here. Pay particular attention to what happens in the mid, I'll call it the decades. Pay attention to what happens in the mid 70s. That's when things really took off, as you remember from the previous chart. So here we go. 1880s, 1890s, 1900s, 1910s, 1920s, 1930s, 1940s, 1950s, 1960s, 1970s, 1980s, 1990s, 2000s, 2010, and finally ending up at 2018. So a couple conclusions here, just quickly. The land is warming faster than the sea, but the sea is warming, that's for sure. The farther north you go towards the Arctic, the more warming is occurring. In fact, the Arctic is warming about 2 to 3 times faster than the rest of the globe. It's not warming everywhere. Notice that there are patches of blue here where it's actually cooling. Generally speaking, those areas have to do with changes in ocean circulation. As the climate is changing, the ocean circulation is also changing. So what's going on here? Well, in fact, it is the greenhouse effect. And the greenhouse effect is best interpreted in terms of the Earth's energy budget, which is depicted here. And the Earth's energy budget is all about radiative flows. It's all about the heat coming in from the sun and radiation going back out to space. Now, you might look at this diagram here and say, well, what about other sources of heat? What about heat coming from the Earth's interior? After all, that's how geothermal energy works. Well, that does happen, but the fact of the matter is it's very, very small. It's extremely small compared to the incoming solar radiation. What about waste heat from buildings? What about anything you can think of? It's really small compared to the energy flows depicted on this diagram. And in fact, what really determines whether the Earth is warming up or cooling or staying the same, whether the climate is changing or not, comes down to a balance of these 3 numbers right here. The incoming solar radiation, the reflected solar radiation going back out to Earth, and the outgoing long wave radiation or infrared radiation that goes back out and cools the Earth. And in fact, the sum of those 3 numbers totals to this number down here, which is the net heat absorbed by the Earth. If this number is 0 down here, which means these 3 numbers sum to 0, then the Earth is going to neither warm up or cool down. If it's positive, then the Earth is warming. If it's negative, the Earth is cooling. So the greenhouse effect works like this. It's pretty simple, actually. Incoming solar radiation warms the Earth, which we were just talking about here. Then reflected solar radiation, reflected by clouds, reflected by the surface, particularly snow and ice areas, cools the Earth. Greenhouse gases, and also I should say back up here, outgoing long wave radiation, that is infrared radiation, cools the Earth. Greenhouse gases in the atmosphere trap the outgoing long wave radiation, warm the lower atmosphere and the surface of the Earth. And human activities increase the greenhouse gases in the atmosphere and increase the warming. And yet the gases of particular interest are carbon dioxide, methane, nitrous oxide, and the F gases are fluorinated gases. About 72% of the warming that's occurring is a result of CO2. And we humans are putting about 40 billion tons of CO2 into the atmosphere every year, putting CO2 in the atmosphere about 2 to 3 times as fast as the natural carbon cycle can take it out. So why is this important? Well, one thing you should know is the greenhouse warming that's occurring is occurring in the lower atmosphere. In fact, the lower half of the troposphere. This is a schematic diagram of the vertical structure of the atmosphere. The lowest layer of the atmosphere is called the troposphere. That's the region from the surface up to about 10 miles height. That's where all the weather occurs. If you're flying in a jet airplane, you're at the top of the troposphere here, and the pilot will say, we're going to fly above the weather, go up a little bit higher here. All the weather is occurring in the troposphere. And the greenhouse effect is actually warming the atmosphere only in the lower half of the troposphere. Everywhere above the atmosphere is cooling, and that is making the atmosphere more unstable. You're warming the atmosphere from below, cooling it from above. Warm air rises. That warm air rising into cool air produces the energy of storms. And so you're making the atmosphere progressively more unstable. At the same time, you're making the atmosphere more humid because as the oceans warm up, there's greater evaporation, and that's making the humidity go up as well. And of course, that humidity also makes the atmosphere more unstable because as there's condensation in clouds, that releases heat, and that drives more vertical motion, again, the energy for storms. So these changes are fueling increasingly strong storms and severe weather. And you can see that in this plot here. This is a plot of global number of severe weather events by year from 1980 through 2010. Severe storms in green, severe floods in blue, and topical for us, of course, heat waves, droughts, and wildfires in yellow. And you can see there's been a clear upward trend over this period of time. Now, in addition to this increase in severe weather, We also have sea level rise. As the oceans are warming, they're expanding, and that thermal expansion drives sea level rise, but also grounded ice, that's ice that exists on land. For example, mountain glaciers and the ice sheets that cover Greenland and Antarctica, as they melt, that water flows into the ocean, and that causes the sea level to rise. What we're looking at here is sea level rise from 1900 through 2015. And the blue here is from tide gauge data. The red is from satellite altimeter data. There's these satellites up there that can actually measure the sea level very accurately. And you can see that over this period of 115 years, the sea level has risen globally about 8 inches. But the disturbing thing here, and you can see it in this chart, is the rate of sea level rise is accelerating, and it's rising and accelerating at an accelerating pace. So sea level rise is a big problem. Now, there are many other impacts, both natural impacts and impacts on human consequences that flow downstream from these changes. I'm not going to take the time to talk about those, but there are lots of things going on there. Now, this is not just me talking. There is a overwhelming global scientific consensus on this matter. And that is illustrated, for example, by this list of leading science organizations that have made formal declarations confirming human-induced global warming, including the most prestigious organizations in the US, as well as the organizations that have purview over the atmosphere and the ocean in the US, and it's all around the world. Indeed, about 90%, about 97% of scientists in climate-related fields worldwide agree that the climate change is happening. Human activities are causing it, and it is a serious problem. This is a huge consensus. For example, how often does a poll or vote in Congress reach this level of consensus? Pretty much never. So it's a huge consensus, but still there is a legitimate question, and that is, what about the remaining 3%? What about the remaining 3% of scientists in climate-related fields who don't agree to what I've been telling you? Well, in my judgment, the 3% of scientists who don't accept human-induced climate change fall mainly into 3 categories. And the first 2 categories are, one, scientists employed directly by the fossil fuel industry. That's, climate change person, a climatologist working for ExxonMobil. Second category are scientists employed elsewhere, but who depend on the fossil fuel industry or foundations with large equities in the industry for much or all of their funding. So it's a university researcher who's getting much or even all their funding from, say, Texaco. These 2 categories are not that interesting. They're kind of, they bring a quote from the American author Upton Sinclair comes to mind, and that is, it's difficult to get a man to understand something when his salary depends on his not understanding it. So pretty clear what's going on with these guys. They're basically funded by the fossil fuel industry to give the fossil fuel industry the answer they want. So not too interesting there. Pretty obvious what's going on. The third category is much more interesting. These are scientists who are contrarians by nature. They look at the world differently than others and are generally interested in trying to overthrow the conventional scientific consensus. Now, the thing you should know about contrarian scientists is that they're almost always wrong. Theories put forward by contrarian scientists are almost always wrong, but occasionally, God bless them, they are right and they change the world. So let me tell you a story about a young German physicist, marginally employable, couldn't get a real job, couldn't support his family very well. He had to immigrate from Germany to Switzerland. He took a job that was well below his educational credentials. He had a lot of free time, and he spent a lot of time trying to overthrow what was an absolutely overwhelming scientific consensus at the time. He was trying to overthrow the ideas of one of the greatest and perhaps the greatest scientist of all time, Isaac Newton. And he changed the world. He changed the world. He changed the way that we see the universe. He was a contrarian scientist who changed the world. But here's the thing. There was a Nobel Prize waiting for Albert Einstein. And there is a Nobel Prize waiting for anyone who can overthrow the international scientific consensus on climate change. So far, no such prize has been claimed, and in my judgment, no such prize will ever be claimed. In fact, there is an overwhelming international scientific consensus on the following 3 points. Number one, over the past 120 years, the Earth has been warming and the climate has been changing at alarming rates. Number two, this global warming and climate change has been driven almost exclusively by the accumulation of greenhouse gases in the atmosphere caused by human activities. And point three, without dramatic reduction in the emission of greenhouse gases into the atmosphere, the Earth will continue to warm and the climate will continue to change to the detriment of humankind. So succinctly, point one, it's happening. Point two, humans are causing it. And point three, it's not a good thing. So even in light of that overwhelming international scientific consensus, there is a robust climate change denial community out there. Here's an example. These are people out here demonstrating global warming is a fraud. It's a huge fraud. Drill here, drill now. Yes, coal, clean, carbon neutral coal. CO2 is not a pollutant. I love CO2. Total eclipse of the truth. Solar activity, not carbon emissions, controls all weather and climate. Be happy, not conned. There is a robust and vigorous climate change denial community out there. They are supported by literally hundreds of websites that put forth climate denial ideas. They're supported by a rather robust literature out there. Lots of books you can find out there that talk about the climate change hoax. Here's poor Al Gore down here with a headache from all this going on. I see a lot of parallels between the climate change denial community and, quite frankly, the Flat Earth Society. This gentleman here is one of the leaders of the Flat Earth Society, and what he's holding up here is a model of the Flat Earth. You can find dozens of, if not hundreds, at least dozens of videos out there on YouTube where Flat Earth Society people who are very sincere, they really believe what they believe, and there are thousands of them, that the Earth is flat. They adhere to this model right here, which says that the Earth is flat, and what we perceive as or consider to be Antarctica, in fact, is actually a band of ice that goes all the way around here, and that's what holds the water in. We're not quite sure what's on the bottom there, but we do know the Earth is flat. And they sincerely believe this. There's no doubt about that. Now, just like the climate change denial community, they are supported by lots of literature out there. There are lots of books out here, the Flat Earth Theory here, Greatest Lie on Earth. 100 proofs that the Earth is not a globe. If one's not good enough for you, you got 99 more. Top 5 flat Earth conspiracies, the Flat Earth conspiracy. Now, the word conspiracy here is very relevant because, quite frankly, the overlap between the Flat Earth Society and climate change deniers is the commonality here is conspiracy theories. If you're a flat earther, you believe there's been a huge conspiracy theory that's been going on for centuries, where the elites have been trying to trick you into thinking the Earth is a globe, and in fact, it's really flat. If you're a climate change denier, you believe there is a huge conspiracy going on among all the scientists of the world. 97% of these scientists of the world are trying to convince you that, in fact, global warming is caused by man, but indeed it's either not happening at all or it's being caused by something else. So a lot of overlap between the Flat Earth Society, the flat earthers, and the climate change deniers. And in fact, I would dare to say that the flat earthers to a person are probably also climate change deniers, because indeed, it's pretty hard to believe in global warming if you don't believe we live on a globe. Now, I've made a lot of fun of the climate change, or I should say I've spoken disparagingly of the Flat Earth Society, but I have to tell you that there's one thing that I truly admire and respect about the Flat Earth Society, and that is they got really cool t-shirts. Now, this is one that was apparently produced by a flat earther who has a backyard telescope, so he can see that all the other planets are spheres, but we're flat for some reason. Here's one that applies to the younger crowd. It's flat, bro. And there's the Flat Earth model there. But this next one is my favorite one of all. Flat Earth Society, members all around the globe. So, on a slightly more serious note, I'd like to read this statement to you. And this is from an article on the effect of CO2 on climate. There is evidence that the amount of carbon dioxide in the Earth's atmosphere is increasing rapidly as a result of the combustion of fossil fuels. If the future rate of increase continues at its present, it has been predicted that because the CO2 envelope reduces radiation, the temperature of the Earth's atmosphere will increase and the vast changes in the climates of the Earth will result. Such changes in temperature will cause melting of the polar ice caps, which in turn could result in the inundation of many coastal cities, including New York and London. Now, this is a remarkable statement, not because of what it says, but because who said it and when it was said. This, in fact, came from an article called Air Pollution in the Coal Industry, which was written by James R. Garvey, who was president of the Bituminous Coal Research Incorporated, and it appeared in the Mining Congress Journal in August of 1966. And there are similar statements and articles that were produced by the oil companies way back in the 60s. The point is, they knew back then that their product was going to be causing this problem, that there was this problem of climate change. And to avoid taking responsibility for that role in causing climate change, the fossil fuel industry and its allies have organized a climate change denial campaign to disseminate disinformation to the public for decades, attempting to create the appearance of scientific controversy where there is none. This strategy is completely, perfectly analogous to the organized denial of the hazards of smoking by the tobacco industry in the 1950s through the 1990s, and even involves some of the same PR firms. In the 1950s, it became apparent that people were dying of heart attacks, and there were other issues that were associated with smoking, and very aggressively, the tobacco industry began funding people to try to create doubt around that science. And that is exactly what the fossil fuel industry has been doing. Now, the campaign to undermine public trust in climate science has been described as a denial machine and is largely carried out by about 90 think tanks, advocacy groups, trade associations, and lobbyists that are funded at about $1 billion per year. Put that in perspective, the total US government funding of climate science is about $2 billion. So they're kind of up in that ballpark there. And this would involve the Global Climate Coalition, George Marshall Institute, Competitive Enterprise Institute. You probably heard of some of these. Center for Study of Carbon Dioxide and Global Change, the Heartland Institute, Cato Institute, Mercatus Center, Frontiers of Freedom, Americans for Prosperity, et cetera, et cetera. Most of the funding comes from the fossil fuel industry itself, for example, ExxonMobil, Chevron, Shell, American Petroleum Institute, et cetera, as well as from conservative billionaires and foundations with large holdings in the industry. For example, the Koch Foundation, Templeton Foundation, DeVos Foundation, et cetera, often working through secretive funding networks in an attempt to hide conflicts of interest. This organized climate change denial effort has had a significant political impact by creating doubt in the public and inaction among some politicians, and thus undermining the federal government's resolve to deal with climate change. That's kind of the political aspect of climate change denial. There's also a significant psychological aspect to it. I'd like to quickly talk a little bit about that. In theory, resolving factual disputes should be relatively easy. You just present evidence of a strong expert consensus, which of course exists for climate change. But things don't work that way when the scientific consensus presents a picture that threatens someone's ideological worldview. In practice, it turns out that one's political, religious, or ethnic identity quite effectively predict one's willingness to accept expertise on any given politicized issue. And climate change, unfortunately, has certainly become a politicized issue. Now, there's a reason for this. Our ancestors evolved in small groups where cooperation, and I mean going all the way back to caveman days, where cooperation and persuasion had at least as much to do with success as holding accurate factual beliefs about the world. Assimilation into one's tribe required assimilation into the group's ideological belief system. An instinctive bias in favor of one's tribe and its worldview is deeply ingrained in human psychology. That's the key statement here. And of course, we very much live in tribes these days, no doubt about that. People respond automatically and defensively to information that threatens their ideological worldview. They respond with rationalization and selective assessment of evidence. That is, they engage in confirmation bias, giving credit to expert testimony they like and simply rejecting the rest. This explains a wide range of extreme evidence-resistant rejection of historical fact and scientific consensus, including climate change denial. This is an article by Adrian Barden called "Humans Are Hardwired to Dismiss Facts That Don't Fit Their Worldview," and I think it's quite good. So what's the future of climate change denial? Well, ultimately, the efforts of the climate change denial community will fail, just as the efforts of the tobacco industry failed. And government will be able to act more decisively in dealing with climate change. For example, a September 2019 CBS poll found that among Americans, about 91% agree that the Earth is experiencing climate change in some way. About 70% agree human activity contributes a lot or at least some to climate change. And about 64% agree climate change is a serious problem. These polling results are very encouraging and reflect significant progress in the public's understanding of climate change, despite the well-funded efforts of the climate change denial community. Now, it will take time for our political leaders to catch up to the public on this issue, but eventually they will. And ultimately, the arguments that have been put forward by the climate change denial community will someday seem as wrong and as out of place as a 1950s vintage cigarette ad. So the next time you visit your doctor, ask him or her if he or she recommends Viceroys, Camels, or Luckies, and see what kind of reaction you get. So it needs to be done. I highly recommend a website called drawdown.org. It's called Project Drawdown. It's a nonprofit organization that proposes, analyzes, and ranks solutions for reducing greenhouse gases in the atmosphere with the goal of reaching drawdown, the point of a time when the concentration of greenhouse gases begins to decline on a year-to-year basis. It was founded in 2014 by Paul Hawken. It presents 80 solutions for reducing greenhouse gases by avoiding emissions and or by sequestering carbon dioxide already in the atmosphere. The solutions consist of technologies, practices, and policies organized into 9 sectors and implemented in 2 scenarios, and essentially provides a roadmap for stopping and eventually reversing global warming and climate change. We don't have time to go over this, of course, but I just want to point out that there's 9 drawdown sectors. They organize these solutions according to these sectors. It's really a worthwhile read. If you go to their website, they have a book out as well. It's really quite good, and it really provides the roadmap for how we need to proceed to address this problem. Now, there's a cost associated with this. It doesn't happen automatically for free. And in fact, Drawdown has done a great job of analyzing, not only ranking and analyzing solutions, but also costing them out. And they do it in 2 scenarios. Scenario 1 is whole global warming to 2 degrees centigrade by the end of the century. And scenario 2 is the whole global warming to 1.5 degrees centigrade by the end of the century. This is sort of the overall Paris Accord goal. This is sort of the stretch goal for Paris. This is where we'd really like to get to. And in terms of the 30-year costs for the world, scenario 1 would amount to, over the 30-year period, to about $23 trillion, which would be about 1% of global GDP per year. And scenario 2 would be about 30 trillion over that time frame, which is about 1.25% of global GDP over that year. Costs spread out, of course, over all the countries of the world. Now, the good news here is there would be cost savings. The 30-year cost savings to the world for scenario 1 would be about 95 trillion, and for scenario 2, about 145 trillion. So you invest 30 trillion to save 145 trillion over this period of time. Now, if these costs were apportioned out according to GDP, then the US share of this would amount to, for scenario 1, about 190 billion per year, and for scenario 2, about 250 billion per year. And that's a lot of money, but it's a lot less than, for example, the defense budget. And the annual cost savings would be significant, for scenario 2, exceeding $1 trillion per year. It's also interesting, also worthy of note that there's money out there that could be used to tap into this. For example, according to the IMF, the International Monetary Fund, the US fossil fuel industry is currently subsidized at about 650 billion per year. Now, the US government doesn't write a check for 650 billion per year to the fossil fuel industry, but it gives the fossil fuel industry 650 billion per year in top tax subsidies and tax breaks. If you just reduce that by a factor of 2, there would be plenty of money to make the necessary investments here. And that's something I believe needs to be done. So closing comments, and we'll open up for questions. What are the actions you can take as an individual? Well, you can learn the basics of the science behind why our planet is warming and the climate is changing. We touched a little bit on that today. You can do what you can to reduce your carbon footprint while living the life you want to live. You can join an advocacy group such as the Citizens Climate Lobby and participate actively. I can tell you we do have a very active Monterey chapter of CCL, and we'd love to have you join. Whenever you have an opportunity to interact with a leader in your community, be they political or otherwise, let them know that you want to see action taken on this issue. Become a leader in your community in this issue. And of course, I know many of you already are leaders for sure. And finally, vote for candidates who will address your concerns about climate change. And let me just put in a plug here for our Congressman, Jimmy Panetta. He has been a great leader in the Congress on this matter. He's a member of the Climate Solutions Caucus, and he has authored one of the 3 bills that are going forward in Congress on addressing climate change through carbon pricing. And he's been a very great friend of CCL, and he's been a really good leader on this. So that's it. And I'm going to now stop the share and open it up to questions. Who has a question?
So Cynthia Hall has a question. Cynthia, unmute yourself.
Yes.
I heard President-elect Biden give a speech, I think it was in Pennsylvania, and he spoke to fracking. And,
Yes.
and he wasn't totally against it, which kind of surprised me. So I was wondering what your thoughts were on fracking.
Yeah, Biden's position on that is he opposes fracking on federal land, but he's not opposed to it on other land. The amount of fracking that's done on federal land is actually quite low. Well, the bottom line is we really need to make the transition to renewable energy. I mean, we really need to do that to get where we need to be and get things under control by the end of this century. We really need to achieve carbon neutrality by 2050 and bring our emissions pretty close to zero by the end of this century. That means we need to leave all of as much as possible, we need to leave fossil fuels in the ground. And that includes fracking, of course. Fracking is a process whereby they fracture the rock to remove methane and some oil. And there's a lot of very detrimental side effects associated with fracking. There's a movie out called Gasland. You can probably Google that or find it. It talks about some of the things that happened when they started doing fracking, in Pennsylvania. Lots of problems with water, gets in, the water supplies, and there's lots of issues there associated with fracking. I'm not a big fan of fracking, that's for sure. What we really need to do is make the transition to renewable energies, and the technology is there, and there's a lot of renewable energy out there, and it's a good news story for us in the West because there's a lot of renewable energy resource in the West.
May I ask you one more question?
Sure.
What about coal mining? I grew up in southeastern Ohio, and coal mining was huge.
Yes.
So what are your thoughts on coal mining?
Well, of all the fossil fuels, coal is the dirtiest. It's the most polluting. You get more, it's not just with CO2, but also with aerosols that are detrimental to health. We built this country on coal. Thank God for the coal industry in the first half of the 20th century that built this country. That was the right answer back then, but it's not the right answer now. We have other sources of energy, and coal's in decline. I know President Trump came in saying we're going to save your coal mining jobs. We're going to bring back coal mining, but coal mining is in decline, driven in decline to a great extent by fracking because natural gas has become much more cost effective than coal. So the coal mining industry is on the decline. We need to let it go on the decline, and we need to shift to renewable energy, and that's for sure. Coal is the most polluting and the dirtiest burning of all the fossil fuels.
Thank you.
Mm-hmm.
The next question is from Allison.
Thank you.
Hi, Allison.
Mike, thanks for your presentation. It was nice to hear you.
Thanks.
Can you talk a little bit about the new Green Deal and how that tracks with your thoughts of moving us forward?
Yeah, the Green New Deal, of course, is not a specific piece of legislation. It's a sort of a general framework for goals, and it's very aggressive. The Green New Deal sets out, the sort of Paris Accord aggressive goal to hold warming to 1.5 degrees centigrade requires getting to carbon neutrality by 2050. That's 30 years from now, and I think that's going to be very difficult to achieve. Well, the Green New Deal says we're going to do it in 10 years. We're going to do what would be hard to do in 30 years. We're going to do in 10 years. I think it's pretty unlikely that's going to happen. I think it's good to spell out a lot of goals. One thing you should know about the Green New Deal, the climate change aspect to it is actually, it's only part of it. It's only maybe a third. There's a lot of aspects of the Green New Deal that have to do with social justice and that kind of thing, and don't really specifically speak to climate change. But the part that does speak to climate change is very aggressive. And I'm not opposed to aggressive goals. I mean, you have aggressive goals and maybe you fall short of them, but it's good to set the bar high. The Green New Deal, of course, came under significant attack from the right wing. And there were lots of pretty wild claims being made. It reminded me a lot of Obamacare. When Obamacare first came out, it was attacked from the right. And you heard things like death panels. There's going to be these death panels out there and going to decide whether your grandmother is going to live or die. Well, Obamacare has been around for quite a few years now. Haven't met a death panel yet. And then in terms of the Green New Deal, they talked about, well, you're going to get rid of all the airplanes, right? Be able to fly anymore. There's not any more jet airplanes. Well, that's not true at all. So there's been a lot of pretty wild attacks there, and I think it does provide a useful, although I think overly optimistic and aggressive framework. But I think in general, it's good to have those aggressive goals out there.
Karen Strasser-Kaufman next.
Yeah, can you hear me?
Hi,
Yeah.
Karen. How are you? Yes.
Okay. There are so many things that need to be done and so much effort and money that needs to be invested.
Yes.
For those of us who really can't wait until the end of the century, who want as quick a result as possible, whatever it takes, what 2 or 3 actions or investments or energy, contribution is required to get us there the quickest?
Yes, I mean, what can we do personally is what you're asking me. Is that what you're saying? What can we?
Personally, and as a society and as humankind on the planet, yeah.
Yeah. Well, the number one thing we need to do is we need to reduce greenhouse gas emissions, and the best way to do that is through switching to renewable energy for electrification of the power grid. Most of the greenhouse gases emitted, well, the top 3 sectors are, number one is electrification of the power grid. So we need to switch from coal-powered and gas-powered fired power plants to wind, solar, hydro. And that's happening. And we want to do everything we can to accelerate that. And ultimately it will happen because it just makes good business sense. It just makes good business sense. It turns out it's actually cheaper to replace a gas-fired power plant like Moss Landing, for example, with a solar array than it is to rebuild another gas-fired plant. So ultimately the economics are going to take us in the right direction. I always like to talk about what state is leads the country in wind production. Well, it's Texas. The ruby red oil producing state of Texas leads the country in wind production because it just makes good economic sense, and they got a lot of wind power down there. So, but we want to accelerate that as much as possible. So we want to have the government invest in moving towards wind and solar and more use of hydro. We want to move towards electric vehicles and that sort of thing. Food production is a big part of it. It turns out that the rest of the world looks to us, and as the rest of the world gets richer, they want to sort of have our diet, which is a heavily meat-oriented diet. And it turns out that agriculture is actually agriculture and land use is actually the second largest producer of greenhouse gases. We want to try to get away from sort of the meat end of the spectrum, particularly cattle and pork, dairy, more towards the plant-based diets, and we would like to have the rest of the world kind of do that too. There's lots of ways we can do agriculture better, regenerative agriculture that will produce less greenhouse gases. But a big issue is deforestation. There's huge amounts of deforestation going on around the world. You've probably heard about what's going on in the Amazon. They're losing about one and a half soccer fields per minute to deforestation in the Amazon, mainly driven by the need to grow palm oil. Palm oil is a big driver of deforestation all around the world. So we need to stop the deforestation. We need to plant more trees, those kinds of things. Steel and cement production is the next largest sector. We need to use alternative forms of cement. Cement production is a very large source of CO2. Those kinds of things.
And individually?
Individually, taking a look at, the food you eat, trying to get away from eating as much, meat as we traditionally eat in the Western diet. It's actually more healthy. That's a big part of it. Throwing away less food. The world throws away about 1/3 of the food produced. And just by throwing away less food, you can really have a big impact. You want to eat locally. You don't want to, if you want to eat lobster, you don't want to fly that lobster in from New England. You want to get a lobster that's caught here in California, that kind of thing. Rooftop solar is a good thing to do. Insulating your house. There's new technologies out there that you can make homes much more efficient, energy efficient. Rooftop solar is a good choice now these days. Those kinds of things.
Okay, Howard is next, and after that, Jim Emery.
Thank you. Mike, could you talk a little bit about your views on hydrogen as a fuel and what effect it has on global warming?
Are you talking about fusion, nuclear fusion?
No, I was thinking about hydrogen that's manufactured for automobiles as a fuel.
Okay, yes, right. Great. I think that's part of the future. I mean, what you would have would be envisioning where we'd like to be. You would have, vast solar arrays out on the deserts in the West. And those arrays would be providing the electricity required to electrolyze water into hydrogen and oxygen. Then you have that hydrogen, you can compress that. That becomes a very energy intensive fuel, which could be used to fuel airplanes, for example. It certainly could be used to fuel cars. And when you burn that hydrogen, you end up with water again. So it's very much non-polluting, but you have to start with renewable energy. You're not going to want to power your electrolysis to get the hydrogen from a coal-fired power plant. It needs to be coming from energy. But I think hydrogen fuel cells, hydrogen power will ultimately coming from green energy will be an important part of the solution in the long term.
Jim?
Trump made a big political issue of the climate change, and he was against it pretty much because of employment. Could you comment about the employment effect of just one portion that you talked about, the electrical generation industry? If you look at employment losses in coal industry and fracking and so on, and compare that to the employment achieved through generation of solar devices and so on, how do those compare? Is there much of a employment effect?
Well, there is, and that's going to be a big part of what I'm sure President-elect Biden is going to be pursuing. He's talked about it already. There are lots of jobs out there in the renewable energy field. Lots of jobs in the putting up the wind turbines and deploying solar arrays, and you can see it all around us. I mean, look at all the companies that are now advertising rooftop solar in addition to roofing or whatever. It's lots of jobs are out there. The problem politically was that there are certain states that were swing states, and President Trump masterfully maneuvered votes there, and a lot of those states had to do with coal production. And of course, in 2016, Hillary Clinton went to West Virginia and said, if I become president, I'm going to put you out of business. And the next sentence was, and find you really good jobs in green energy. But of course, that second sentence was chopped off. And the first sentence was, I'm going to put you out of business. I'm going to put the coal industry out of business. And of course, that cost her a lot of votes in a lot of crucial swing states. So those issues kind of go on. But if you look at the overall numbers of jobs, I think it's a big growth industry. I think the pace of job growth in the renewable energy field will far outpace the jobs that are being lost in the fossil fuel industry.
Amy Anderson, next.
Good presentation, Mike. Very, very
Thank
interesting.
Thank
Good graphics.
Thanks.
California is a huge producer of, food for the whole country, more than just the whole
Yes.
country. What kind of
Yes.
percentage of our CO2 emissions from the trucks that are driving around delivering food could be reduced by some other kind, and I don't know what other kind of transport that could get food kits quickly enough?
Well, generally speaking, we do need to
What's
move
the
away.
plan?
Yeah. There are trucks that are being developed that are electric powered, and I think just as we are going to see and are seeing, gasoline powered automobiles kind of going down, and more often you're seeing electric vehicles on the road. The same will be true of the trucking industry as well. And if you fast forward maybe 10 or 20 years, I think it's going to be you may find it rare to find a diesel powered truck out there. You'll find electric powered trucks charged by an energy grid that is powered ultimately by renewable energy, wind and solar. That's kind of the future we need to look to, and that's the future where we're going. In terms of California's emissions, there is actually a pretty good news story for us. California produces about 3% of global GDP, but only about 1% of global emissions. So we're doing pretty well compared to the rest of the world. We're doing pretty well compared to the rest of the United States. The average carbon footprint for the average American is 17 tons per year, but for California, it's down to 11 tons per year. So we're actually doing pretty well, both globally and nationally, and keeping our emissions down.
I have a question. Transportation emissions account for about 28% of CO2 emissions. A twofold question. The pandemic has resulted in a reduction in travel because people are working at home and not commuting. And so I would like to know what your thoughts are, if that's going to continue or not. The second part of my question is a focus on good land use planning as a way to reduce travel, such as urban growth boundary that was just adopted in Marina, for example, encouraging compact growth. So could you comment on those two items?
Yes, the first thing, 28%, that's for the US, but globally, transportation is only about 12% of global emissions. So that just reflects the fact that here in the US, we drive a lot of cars. We drive a lot, whereas most of the people in the world don't have cars. So in terms of globally, transportation is actually pretty far down on the list compared to those other ones I talked about. But we want to move more towards use of electric vehicles and hybrid vehicles that are going to be more efficient and that sort of thing. And the second thing was what you asked about land use planning. Yeah, that's a big part of it, including, city planning. How do you make cities more bicycle friendly, more walking friendly? How do you get people to use public transportation rather than drive their cars? That's a big part of it. How do you make cars more efficient? How do you get people to, go with electric vehicles? Those are all kinds of things where we need to go.
My other question related to the effect of the pandemic on commuting.
Oh, I'm sorry. I knew I was forgetting something there. Yeah, I actually gave a whole talk on that a while back. I've given a couple of talks on that and took a look at what was happening there. And the reduction was significant, but short-lived, basically. That's the problem. The reduction in emissions was really short-lived. And as government started opening things back up again, emissions going back up, the real concern is it may actually have a rebound effect that will be damaging. There's going to be, as the global economy, as countries are trying to get the global economy, back to normal, say next summer after hopefully the pandemic is behind us, there will be a real temptation to move quickly to make use of fossil fuels and looking for cheap energy to get the economies rolling again. Of course, that's fossil fuels that are out there. So there is a concern that there'll be a rebound effect that will more than compensate for what we've lost. But the fact of the matter is, what we held down from in terms of emissions was really pretty minimal. We need to decline even faster and keep that decline going. The pandemic impact, I think, has just been a temporary thing. And also there may be a rebound effect that actually we end up worse off. So I was pretty negative. I looked at all the different aspects of the pandemic and the impact on climate. And my conclusion was it wasn't going to have any significant impact on helping us address climate.
And one of the side effects is impact on public transportation. Transit is suffering because of the lack of use.
Yeah, certainly jet airplane travel is continues to be way down around the world, but it's actually pretty low on the list compared to everything else that puts emissions into the atmosphere.
Okay.
Land use is a big one. You know, land use is a big one, particularly trying to preserve our green areas, particularly trying to take care of our forest, trying to plant forests where no forests have been before, looking at things like use of bamboo, which is an excellent sequester of greenhouse gases, those kinds of things.
What about improved ag practices that encourage increased sequestration?
Absolutely, that's a big part of it. If you take the time to look into that drawdown.org website and look under the agriculture sector, you'll find a lot. You'll find at least a dozen or so different ideas. Regenerative agriculture. The idea there is things like using less fertilizer. You know, the nitrogen-based fertilizer turns into nitrous oxide, which is an important greenhouse gas. Doing less plowing. The plowing tends to disturb the soil, and then the CO2 that's been sequestered in the soil then gets released. Those kinds of things. Lots of use of older style, traditional style forms of agriculture, as opposed to the kinds of agriculture we've been doing in recent decades.
I find this very enlightening, very, very,
Thanks,
very topical and just critical information, Mike. So thanks so much for sharing with us today.
Well, thanks so much for inviting me, and thanks again to Jim Emery for inviting me in the first place. I really appreciate it.
Yeah, so we will look forward to having you back again. And just wanted to mention, in January, you had said one of the things that we can do is talk to our representatives about that. And in January, we'll be hearing from Robert Rivas, our legislative representative in the state legislature, to hear what he has to say about it, that, and we'll have a face-to-face time to ask him some of those questions. So
that's great. The
that.
state has been very.
Thank you so much for joining us all.
All right. Thanks so much. Thank you.
For everyone. It's been a pleasure seeing all these faces again. We look forward to seeing you again soon.
Thank you.
Thank you, Mike.
Thank you.